That's the code.
All righty, everybody. Here we go. We're going to give this a shot. Frame It Fridays. All right. So, first things first. This is a plan. This is a plan that I had drawn, pulled the information off, plopped a floor plan over here, plopped the roof plan right here. This is what we're going to care about. This is what we're going to look at. I will show you the elevations on the sheet behind this so you can get an idea of what the house looks like. But otherwise, this is pretty much all we need to do to look at the bird's eye view of what we care about in terms of the structure. Now, first of all, I am Sam Stevenson. I am someone who has spent about 2 years doing what I'm about to show you right now as an engineer. And I basically, the steps I'm literally showing you with paper and highlighter is what we used to do in the engineering office. So I am literally showing you what we do to wrap our minds around what a house is doing. And that is what we're going to do. Now, you're going to learn in this process how to look at a set of plans, a roof lines, and a ceiling plan, and understand what your framer is going to be doing. That is the purpose of what we're doing here. So hopefully by the end of this video, you've got a slightly better idea of how that works. And we're going to explain the tools here real quick, real simple. I have a scale here. Everything's drawn at a quarter inch per foot. Super simple. I'm going to use quarter inch per foot on my scale. I'm just going to use this, and the numbers will tell me in real life how many feet I'm dealing with, feet and inches and stuff like that. That's what this is for. And if you hear a cat, it's because my cat wants to go outside. So that's all the tools we need. All right, so we got a roof plan here, and we got a ceiling plan. That's what we're going to be calling these things. All right. So this is roof, clearly, and this is going to be ceiling. And the reason I call this ceiling is because I'm going to draw all of the ceiling plane on here. So it's going to show ceiling joist, it's going to show beams, it's going to go all the stuff that's intended to sit on top of the walls. That's not the roof. All right, and on the roof plan, I will show you all the rafters. I will show you the purlin lines, braces, where all that stuff's going to go. That is what I'm going to do here. So we have it prepared so that we can do those two things. Now on an engineering document, they would actually go through this and they'd remove all these cabinets, they'd remove all these dimensions, they'd remove all the lines to clean things up a little bit, but we're not super worried about that. So we need to understand before we're going to look into this what a load path is, because that's, generally we're going to move top down through the house, and I want you to understand what I'm referring to when I say something is sitting on something else, right? So let's say I have a block right here, and the block, I have two other blocks to put this block on. Well, I can't put this like straight down on here because there's nothing holding it. So in a perfect world, I'd put a beam in here or something, and then I could put a post or something in here. And now this block can sit on the post, which sits on the beam, and the beam sits on these two things. So when I say load path, what I'm talking about is if this weighs 100 pounds, where does that 100 pounds go, right? There's a path for that weight. Some of it's going to go down through here. Some of it's going to go down through here. And so we just need to understand when we're describing what sits on what, I'm just describing that, hey, there's some weight that's up high, and we need to transfer that weight to the foundation somehow. And we're going to use the framing to do that. That is what we're doing. So that is the load path. All right. Now, when we look at a house, one of the first things we want to wrap our minds around are what are the plate heights, what are the ceiling heights, and what's going on with my walls. All right. So the first thing I'm going to look for on the floor plan is anything that says ceiling heights or plate heights or anything like that. Sometimes the elevations will show that. So these are the elevations. Very simple house. You got this little gable thing going on the front, a little gable in the back, and a little gable off on the front porch. Each end of the roof is a gabled end. There are no hips on the ends of the roof. I've got plate heights listed out here, 9-foot plate height and 10-foot plate height. It's showing that like, hey, the main house is at a 9-foot plate, and this raised piece is starting at a 10-foot plate. And what that means is the framers are going to make sure that this roof plane here starts a foot higher than the other ones. That's kind of what that means. There's not really another way to simplify that, but that's what's going on. So I'm going to look at my ceilings and I'm going to be like, okay, well, that makes sense because I've got a 9-foot ceiling everywhere. Everything says 9-foot ceiling. That's a 10-foot tray. That's fine. 9-foot ceilings everywhere except the center. It says a 10-foot ceiling. Okay. So I know this whole ceiling is going to be raised up 12 inches higher than everything else. And so either that means that this whole box right here is going to be framed out of 10-foot walls, or it means they're going to put a 12-inch pony wall on top of it. Now, if it was me, I just frame it with 10-foot walls because that's a little more structurally clean, and that would be, just a better solution, especially for those exterior walls. But that's that. Okay, so we understand what the ceiling is doing. This whole area is 9 foot, this area is 9 foot, and this area is raised up 1 foot from everything else. Okay, so we've got our mind wrapped around that. Let's go ahead and take a look at our roof plan. So the first thing we want to think about when we look at a roof plan is, what are all these lines meaning? Okay, what are all these dashed lines? So I'm going to highlight the lines we care about, which are going to be the ridges, the hips, and the valleys. All right, here is a ridge. Here's a ridge, ridge, valley, 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 ridge, valley. Okay. Now, I don't care about the perimeter because that's just the overhang that's just hanging out over the house. No big deal. The reason I care about these lines so much is because these lines represent concentrated weight. And what I mean by that is they're going to frame this house up with some rafters. We'll go ahead and use orange. Okay. And I'm going to draw in the rafter pattern. Okay. So there's a few different ways you could frame this, but we're going to presume there's nothing false about the roof. It's all going to be true hips and valleys. So if I just have a bunch of rafters doing this, I'm going to go across the house like this. Okay, and then the same thing happens on this side. I'm just showing what the rafters are doing. So from a top-down view, I'm showing what each rafter would look like. Okay, so over here, the rafter hits the ridge and it also sits on the wall. And it's slanted, obviously. It's top-down. We don't see the slant, but that's what's going on. Okay, and then over here in these sections, our rafters would run like so. And normally they would line up at the hips and valleys, make everything look clean. I'm not super concerned with making it look perfect. Okay, something like that. That's what the rafters are doing. Of course, out here in the front, the rafters will do this as well. So the reason I said these highlighted yellow lines are load concentrations are they are collectors of all the rafters. Okay, so the walls are collectors of the load because the rafter sits on the wall, but that's easy because the wall's designed to carry that weight. And the other thing carrying weight is the ridge or the hip of the valley because that's where the rafter sits on. All right, so this one rafter sits on the wall, it sits on the ridge, and all the roof weight that it's carrying in this little area right here, that area of roofing, which is usually about 3 pounds per square foot, in terms of like dead weight of like the shingles themselves, for example, right? There's a bunch of weight right there, and there's a bunch of weight that you're anticipated in case you're going to work on the roof. That weight is on the rafter, and the rafter is on the wall and the ridge. That's where the weight's going. Okay. And so I care about this ridge and I care about these hips and valleys because the weight's being concentrated there. Okay. Now, how do we get that weight to the slab if it's up here high in the roof? Well, that's what braces are for. Okay. So we're gonna be supporting our ridges, hips, and valleys with braces. We'll go ahead and use pink for that. And basically, basic rule of thumb we can run with, and this people do this a little bit differently depending on where you're building, but what I typically went with was I try to keep 4 feet on center for ridge braces, and I go 6 to 8 for hips and valleys. And that just has something to do with the way the loads are typically distributed and this, that, and the other fancy words. Okay, so let's take a look at this big center ridge first. Very simple. Over here on this side, remember, this is what the gable end looks like. There is a wall here, and your ridge sits right here. So the ridge is actually inside the wall. The ridge is supported here. There's We're already good. All right. So let's go about 4 feet in. And that's where I would take my scale. And if I had my rafters laid out at 24 inches on center, I would know that it's every other rafter, but I don't have that done to scale. So I'd go in here and I could make marks about every 4 feet to scale. I'll just keep going down here. Where are my numbers? There we go. 20, 24, 28. All right, we're supported here on the wall. We go here, here, and here. Okay. So each one of those pink dashes is 4 feet down the ridge that we would like to support if possible. Okay. So let's talk about what a brace might look like. What do I mean a brace? All right. Well, if we have a cross-section view of our roof and this is our ridge, I mean a brace is literally a 2x4 and a 2x4 nailed together in a T style, and it's going to connect up to the ridge and it's going to go down and sit on something else. And its job is to hold the weight in that one spot. It's like a post, and it can be slanted up to an angle of 45 degrees off a horizontal. So I could, in an ideal world, have a wall down here, and I could put the brace right in here. Straight down load, super nice and easy. We're happy with that. Or maybe my wall's over here. That's okay. I can put a brace over here. Maybe I have a wall over here. That's okay. I can put the brace over here. As long as I don't exceed 45 degrees on that angle, I'm okay. Well, in this case, it's gonna, like, depending on the way you measure the angle, but you get the idea. We don't want this brace to go past 45 degrees when we're deviating from vertical. Okay, so that's generally the rule. Now, what does that mean for me when I'm looking top down at my roof? What it means is, let's pick one spot. I have a spot right here. I need to support the yellow line. I got to support this dotted ridge line. Okay, and I'm looking straight down. So I see walls. There are walls close to my spot. But how do I know if I'm going to exceed my 45 degrees? Well, that's usually pretty simple. All right, what we're going to do is we're going to take our scale, and I know that I'm going to find my imaginary circle that I can brace in. And here's what I mean by that. This horizontal distance that I can go out on the plan, if it's a 45-degree angle, it's the same distance as the height between my wall and my ridge. So if I figure out how high above the wall I am at my ridge, plus or minus a little bit, then I know I can go out on the plan that far in a circle. Let me show you what that looks like. All right, so here I am at the ridge. How do I know how high I am right here? I can use trigonometry. It's fairly simple. Here's my scale. This roof pitch says it's a 612. That's nice and simple. All right, so what I'm going to do is I'm going to put 0 on my wall, and I'm going to find out that my roof peak is about 14 feet over. All right, what does that mean for me? Well, at exactly 12 feet over, I'm 6 feet up because pitch of the roof, 612. 12 over, 6 up. That's what it's describing. And so I know right here in my roof plane, I am 6 feet up. And I know my roof goes a little bit higher than that, but the ridge has some depth to it. So, like, I'm just going to basically say that at my ridge, I have 6 feet approximately of wiggle room to brace. Now, what does that mean in terms of my circle I was talking about? Well, that means that 6 feet horizontally from this point in any direction, I could put a brace and land on a wall. Okay. So if I take my scale and I put the 0 here and I make a 6, in all the spots, you can see that that's quite a big circle. And that's important to know because over here in the center, I might be able to use this trick to avoid a beam or something, and that's important to know. Okay. So inside this dotted imaginary circle, I can run a brace. All right. And so I will put a brace. Usually you want to be as vertical as possible. And so I'm going to say, hey, brace from here to here. That's what that means. I'm going to say, like, there's a dot because I'm grabbing the roof ridge and there's a brace running down and landing on the wall there. Okay. And then I've got a wall right here for this one, right here for this one, right here for this one, here for this one, here for this one. I got a wall right there. Okay. So, like, this area is super simple because I got all these walls right below my ridge. Over here, a little more complicated, but it's still pretty simple. I might run a brace over here and a brace over here. They don't have to be at this angle, but I'm doing that for clarity. And I could even stretch this out a little bit. So let's make a dot. And what I need to do is I need to basically have a brace existing at every single one of these dots floating out in space. All right. So this guy, let's see if it's 6 feet to the wall. If I have 6 feet to the wall, it looks like it's pretty close. And so what I'm going to do is know that it's pretty close, and I'm going to say, yeah, go ahead and give me a brace to the wall. And in the perfect world, you'd want that to be as like straight to the wall as possible, but I'm doing it for clarity here. And then same thing over here. I can probably make this brace reach to the wall, and this one's too far because it's 8 feet out from the wall, which is fine. Okay, so I've got these two spots where my ridge is unsupported. That's a problem. I need to deal with that. And I've got, let's check these. This one can reach because that's less than 6 feet. So we'll put it on the wall there. And this one can probably reach because that's less than 6 feet. So there's actually just this kind of one spot here in the middle of the center ridge we got to support. All right, fine. We're not going to put any beams in yet. We're going to figure out what else we got to brace. Okay, let's look at the rest of our yellow lines. All right, anywhere we have one of these points, we got to brace that. And now on the ridge, we want to brace about 4 feet across. So let's just say, well, let's just throw one in the middle here. We know it's supported in the gable. Again, that's the front. The ridge is right there. It's already inside the wall, so it's supported at the wall. Let's put one in the middle on both sides of this. We know we're good there. And then out here, this one's so small that it's already going to be supported in the wall here and here. So it's just fine. We're going to leave it alone. And it's not hardly carrying anything. So that one's good. This one back here will be supported in the wall where we need support here. And we'll do one in the middle. Okay. That's the ridges. Let's talk about the hips and valleys. This is probably too much of a stretch to not brace. And let's flip back to wherever my 1/4 inch. Okay. So this valley is 0 feet to 14 feet down to this point horizontally. That's too far. I need to put a bracing point in the middle. All right. And that's how I'm going to tell. And on this one over here, I'm going to look at it. 0 to 6 feet. It's getting pretty close, and it's like 6 to 8 feet is kind of like the number you could work with. So I'm going to run with that as being fine. And I'm going to look at the roof and say this is not a big roof area. So it's fine. There's not a lot of weight right here. So that one's fine. Okay. So these dots remaining are the ones we have to brace these up onto something. There needs to be something for them to sit on, whether it's a wall or a beam. And naturally, if they can't reach the wall, guess what? They got to go on a beam. So let's take a look at what we got here. We have this one. It looks like it's close enough to this wall. So I would probably, if this was me, I would do this. And I would do this. I'd stretch these out. You want to use as much wall as possible because the walls are free load carrying capacity thingies. Like they're already there. Use them to carry weight when you can. This one's right next to this wall, so there's a little brace here. I can't even hardly see it, but like that one's braced up. We're fine. And then in this center here, what I'd probably do, because it's right in the middle, and it's probably less than 6 feet, I would run one to this wall, and I'd run one back out to the front. I'd put 2 in there, and then I'd know that ridge is fine. Even if it's kind of a stretch for each side, we could put 2 in, it's totally fine. So that's what I would do there. And then I know this whole area is held up, and I'm dealing now with these 2 ones in the garage I need to hold up, and I got to deal with this center area here in the middle of this big open room. All right. So that is holding up the ceilings and yada, yada, yada. Let's talk a little bit about the rafters. Most of the time, your rafters are going to be 2x6s because that's generally cheapest. Sometimes you can value engineer and remove, it might make sense to bump the whole house up to 2x8 if it makes sense for your house. Let me show you why. The rafters, regular old rafters, 2x6s can span about 11 feet horizontally before they need another support. From the wall to the ridge, I have a little over 14 feet. I happen to know that if I go up to a 2x8, then I think, I forget the exact number, but about 14 feet is the limit of my 2x8. So what I'm going to think about is, okay, If I use the 2x8s, I'm going to be pretty close to the code limit. It looks closer to 15 feet, so I think the 2x8's not even going to cut it. I'd have to use a 2x10 on the whole roof, and that's just like not economical most of the time. So what we're going to do instead is we're going to use 2x6s and just know that somewhere between like with the maximum unsupported horizontal span of these rafters can only be 11 feet. Well, what does that mean? Well, my wall to ridge is too far. So let's check the other spots. Where do I need it? That's 10 feet. Valley to ridge is 10 feet max. So it looks like the only spots I'm going to need this extra support are here, 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 and here. Because I am, let me check this. So if I'm down here in the valley, 0 to, yeah, it's pretty close. Okay, so those are the areas I need the extra support. Well, the next thing you want to think about is where you're going to add the extra support. Anywhere as long as you make the rafters span less than 11 feet. And this is what purlins are for. All right, and this is the job of the purlin. Let's say I've got a wall in here, and this is my roof. My purlin is the thing that looks like this, and purlin means a lot of different things, but in this case, this is what I mean. Looks like this, and it's basically going to be a line of braces, and that is a board running the length along the rafters, and it's going to just support the midspan of each rafter. Ideally, I'd put that in the center of the rafters. That's just kind of better load distribution. I would prefer to keep it that way, but in this case, I know I've got a nice wall right here, and again, this angle can be up to 45 degrees. So like we can offset these from the plan view, which is fine. So what I'm going to do is switch over to, let's just make it a thick orange line. Okay, these are my purlins. I'm going to go one about right here. And I only have to go far enough to the point where my rafters are not spanning 11 feet from dotted line to dotted line. Okay, so that's about where I can stop. And I'll do another one right here. I'll do another one right here straight on top of that. And then I've got nothing in the garage here, so we're going to have to contend with that, but I need another one right here. So those are my purlin lines. That means there's going to be a board the same size as the rafter or bigger running this way along the bottom of these rafters. And now I have to hold that up somehow. Well, guess how I'm going to hold that up? I'm going to use more braces. Okay, so let's follow the same 4-foot rule approximately. We need one approximately here, 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 and here. And this is kind of like a, close enough is sort of good enough kind of thing. I would not pull a measuring tape out when inspecting someone's framing and hold them to the exact 4 feet, but I would kind of look. And it's usually pretty obvious because you can just tell because the rafters are spaced 2 feet on center, usually. Okay, let's just do this. I'm just kind of eyeballing the 4 feet. And I know I'm over here, I'm fine. Okay. So now all my rafters have been selected. I need a note somewhere that I'm anticipating using. I should have been specific. 2x6 rafters at 24 inches on center were those spacings. Most of the time, you're probably not going to bump your roof up to 16 inches on center. In this case, if you want to avoid all these purlins, you could probably do the 2x8s, 16 inches on center, or maybe 19.2 inches on center. One of those. You'd have to check the tables in the IRC. Oh boy. I wonder how long that's been off. That's really unfortunate. Okay, here we're going to get caught up here. I don't know how much of that was just cut off, but we got our orange rafters going up and down. We've got our purlins going horizontally, holding the rafters. All these pink dots are the brace points. We have to hold those up. The highlighted yellow are the ridge, hips, and valleys that we got to hold up as well. Let's just keep going. That sucks a little bit. Okay. So this in here, again, very simple. I got a nice wall here, so I'm going to be brace, 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 brace. Done. This side. I know I got 6 feet. Well, I don't have 6 feet to work with because these are lower down in the roof, but I've got something like that. So I'm going to, honestly, I'm just going to draw these running this way, and then they'll just make sure it works in the field, kind of a thing. Like, hey, put this thing where height works. As long as it's in there, be fine. And this side's easy because it's sitting right on top of a wall. So, I mean, just brace straight down to the wall. And this one's right here is tricky because we're over a whole garage. All right, so what is left over? Let's yellow highlight what we need to fix. We're missing support here, 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 here. All of this and these two. All right, those are the places that need love that are not held up right now. And we used all the walls we could. And that means that we could refer to maybe using some other truss tricks or stuff like that. I'm not going to get into how to do that. We're just going to go simple here. So we're going to use beams to solve that problem. Now let's go over to our ceiling plan, take a look at what we're going to do with the ceiling. Okay. So first thing I want to think about with ceiling is which way are my rafters running? They're running up and down across the whole house, except where these gables are, whatever. I know my ceiling is raised 10 feet here, so I just have I got a different ceiling thing going on. And then, yeah, that's what I'm looking at. So now I'm going to think about how do I want to lay out my ceiling joists in here? What makes sense? For ceiling joists, if you're going to use 2x6s, 24 inches on center, you can go 14 feet about. And I think the 2x8s are something a little bit more than that. You'd want to check the code, just so you, of course, know what you're using. You got to refer to those tables.
That's the code. That's the code.
Says Larry Hahn. Thank you, Larry Hahn. Okay, so let's lay out some ceiling joists. On this chunk, I know my whole roof is going this way, and I've got a bunch of simple bracing and stuff going in here. So I just want to run my ceiling parallel with it because it just makes it clean and easy. And I'm going to keep my ceiling joists as long as possible so that it makes sense. So I'll run them all through here. And let's see, I can go up to probably 20 foot with a ceiling joist comfortably, 2x6s, Where's my 1/4 inch? It's right here. All right, so if I go 0 to that wall, that's 18 footer, so that's fine. So now I'm going to run my ceiling joists all the way across this like this. And you may be like, wait, Sam, there's a trade ceiling in there. And I'd be like, yes, you're right. There's a trade ceiling right here. And what I would note here is because of the way you're making the tray, the simplest, cheapest way to do this. So here's a thing that's happening. We got a 6/12 pitch and a 2 foot offset tray going up 1 foot. And here's how we contend with that. If we looked at a wall section, it would look exactly like this. Roof goes up. Here's our wall. That's not correct. The roof is at the edge of the wall. Here's our tray line. Okay, it would be exactly at the bottom of this. Why? Because it's a 6/12 pitch, which means if we go over 2 feet for our tray, we go up 1 foot and we hit the exact bottom of the rafter right there. I have seen houses where people don't pay attention to that spacing and these things conflict. Something you'll want to keep an eye out for. And I happen to see that, like, okay, the simplest way to frame this is going to be to raise all my ceiling joists in this room, let them hang in the rafters, do a little heel block on like underneath the ceiling joist at the edge of the rafter, and then just fur down the rest of the ceiling off of those ceiling joists. Super simple, super easy tray, cheap. You don't need any beams or anything. And then what I would think about is, okay, now in that room, I'm going to hang the ceiling joists on the rafters, which means the rafters no longer can span 11 feet because there's more weight on them. So I'll go check the table. There's a factor thingy at the bottom you can check out. Be like, hey, what's the adjustment I need? Cool, good to go. And I happen to know that, like, yeah, I got this brace in here. It'll all work out fine. So that's what I would do there. So I would make a note with a pen or something if I had one, and I would just say, fur down ceiling to make the tray. So like the real ceiling exists a foot off the walls, and they're going to fur down everything else. Of course, the alternative to doing that is using like real beams on all the edges, if that's the way you'd like to frame it. That would work too. But this is the way I would do it. So yeah, there's a ceiling joist on that side. Let's talk about this side a little bit. Oop. Okay, so I'm throwing stuff now. So over here, Let's keep this simple. Let's run them front to back. Obviously, the ceiling joists aren't going to span across the whole garage. You could buy maybe some 2x12s if you wanted to do that, but like that's not our strategy here. I will show you what we're going to do instead. So those are the ceiling joists. We've got 22 feet across the garage, and our ceiling joists can go 14 feet. 2x6 is 24 inches on center. And so if I break this in the middle with a beam, I can hold my ceiling. And now I've just got my regular ceiling joist, super simple. We'll go ahead and use orange for a beam. So I'm just going to run across this nice and easy with a beam. It's going to sit on that wall and that wall. Going to carry all that ceiling weight. Now remember before, I said we want to keep these roof braces off beams as much as possible. We want them to be on walls. All right. And so now what I did is I just basically, this is confusing because of purlin. I put a beam right here in this garage. So now I'm going to take these two roof braces, put them on the beam, and I can put all of these roof braces on that beam as well. And what I'm going to do is when I calculate the size of this beam, I'm going to be like, all right, what is approximately this area? That's called the tributary area. That's the load area that's putting weight on this beam from the roof. All the other area is going out to the walls. Okay, that's how we'd look at that. And then be like, oh yeah, we're just carrying the whole ceiling in here. So that's cool. That's how I'd calculate that. The reason we want to put the weight in the walls is because the more weight we put on this beam over such a big span that's spanning 24 feet, that's a long span, you're going to have a bigger and bigger and bigger beam very quickly if you start putting a lot of weight on it over such a far span. And we want to keep that number down so we push the loads out efficiently through our house. That's what we try to do as framing. All right. On the patio, we'll keep it real simple. We'll just go left to right because that's the way that this roof is running. So, you know, it'd be what it be. We'll just do that. That's super simple. And that's 12 feet something. So that's less than the 14. Ceiling joists are good there. Okay. So we've got support, 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 support. No spans over 14 feet. Same here. We're good. Let's talk about the center area now. We got these roof thingies to hold, and we need to hold pretty much a line across this. But I know that if I put a beam across this whole thing, that'd be a fat beam because that's almost 30 feet. That's a long span for a beam to go. So what I'm going to do instead is I want to use the shortest possible spans to accomplish the same like load catching scenario. So here's what I'm going to do. I'm going to look at this space and I'm going to say, hey, look, there's actually a little wall sticking out here by the fridge. So I can get a shorter span if I go from that corner of the wall to here. So I'm going to do that. So I'm going to run a beam straight across like this. That's a short span, better placement than if I had used this wall because that's an extra 2.5 feet. And that makes a big difference when you get up to 20 feet of a span. The difference between, 16, 17 and a half and 20 feet is quite significant when you're dealing with beams. So shorter span there. I like that. And that means that the beam exists in my roof plan basically about right here. And so I could put the weight from these braces on here, here, and here. That works. That saves those center spots, but it doesn't save my spot out here and out here. Okay, so that's the last part of my roof that I don't have supported. So what am I going to do? Well, I'm going to probably just have to support them with 2 more beams because I don't have any other cool tricks to do to make that happen. And so what I'm going to do is I know there's going to be a beam running down the center here and running down the center here. Okay. And in the pie of life, they don't have to be in line. They don't have to be perfect because like the braces can always be at an angle. All right. Remember I put the beams basically right here and right here. So now this guy is good and that guy's good because it's going to sit on a beam. And now we can talk about the ceiling in here too. We could run it this way. We could also run it left to right. It really doesn't matter because it's all kind of up in the attic anyway. No big deal. If it was me, what I'd rather do is run it front to back, and here's why. Obviously, so like the methods you use to connect the beams to the ceiling joists, there's tons of ways to do it. You could do it the modern way, which is to drop the beam all the way down to the ceiling level and use a bunch of metal hangers. You could pick the beam up above the ceiling joist. You could use metal hardware to hang the ceiling joist below the beam. You could use wood to hang the joist below the ceiling beam. All kinds of ways to do it. Framers like to do it all kinds of different preferences. It's all the same. It all holds the house up. These beams could be on top of the beam. Like this one could come and sit on top of this horizontal beam. Or again, you could flush the bottoms and use big hangers. Could do that totally fine. I personally try to avoid metal hardware where I can because it adds thickness and kind of complications. And like as a craftsman, it's hard to work with. But here's the reason why I want the ceiling joist to run this way. If I ran them the other way, I'm going to accumulate all the ceiling weight on these two beams because they're going to run like this and they're going to rest and hang on these two beams. And what that's going to do is going to take all that ceiling weight and it's going to concentrate it right into the center of this beam running left to right. And if you want to know something about math, you should understand that beams will handle distributed loads much happier than if they take the same combined weight placed right in the center. The center is the worst spot to put a load for the beam. It's just where it has the biggest impact. So if I do it this way, then each ceiling joist is spreading the load out on this beam just farther away from the center of the beam. And I like that idea. And it's also less than the, oh wait, hold on. That's a little under a 30-foot span. So what I'm going to do is in this section, I know I'm getting close to the 14-foot limit. So I'm actually going to say, hey, use 2x8 ceiling joists in these whole areas. I would say that because that's an easy upgrade to fix that problem without adding more beams. And that wouldn't cost hardly any difference. All right, so that's what I would do. And, if you want to be fancy, you could say, yep, there's going to be hangers in here. They're going to hang. You could specify the loads on the hangers if you find all the numbers, yada, yada, yada. That's how you could do that. And then everything's supported from the roof. Everything's supported from the ceiling. We're happy. Now, we're almost there. We got to talk about headers real quick. Okay, so let's talk about headers. We're not done with all these load combinations and fancy stuff. We have to think about now, we've added beams, and now because we added beams, also there's more beams. On this defining patio edge, there's every edge of this is a beam because that's what's got to hold the roof over the porch because it's open. Okay, so those are beams too. Now that you have beams, you've introduced concentrated loads into your plan. Concentrated load means there's a lot of weight in one spot. So the weight varies based on which beam you're talking about. Could be kind of a little bit, could be a lot. All right. So how are we going to think about that? Well, we're going to look at where's the concentrated loads. Concentrated loads are on the ends of each beam where they sit on the walls. Okay. So technically on the ends of every single beam is a concentrated load. Now, I can look at this plan and tell you that this porch, there's hardly any weight there. Like you do not need to be concerned with how much weight is there. And I can just say that from experience. If you wanted to have an idea, you could calculate things, you could run numbers, but it's just not going to be a big deal. It's going to be less than like 1,000, 2,000 pounds, which is nothing in wood framing. Okay, but the ends of these beams, they might be up in the 2s, the 3s, the 4,000s, maybe 5,000, 6,000 pounds. Like it depends on how big the beams are and what's going on. But those are the concentrated loads we care about. So let's highlight them. We care about the big ones. Here, 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 and here. Okay. Very simple rule. When you put a beam on a wall, make sure that there is solid wood in the wall below the beam that is the same width or wider than the beam itself. You're probably good. That's going to like generally cover your bases because the wider the beam gets, it means, oh, it's a bigger beam. It's carrying more weight. Therefore, the more studs I pack in and make that wider, it can handle more weight. So just a good rule of thumb there. Okay. So you'd want to basically put at least 3 studs below each one of these, possibly more. And in some cases, a 2x4 wall is actually not sufficient to carry the load. So you might upgrade a wall as an engineer. I might say, you know what, this guy is really heavy. This whole wall needs to become a 2x6 wall because I need 3 2x6s or 4 2x6s there to carry this. 2x4s aren't going to cut the cheese. And that is not likely to happen in this house because it's just not a big house. But big custom homes where you've got multiple levels and multiple floors and you've got concentrated loads building up down like through the floor systems, you can get massive, massive loads. I've seen plans and calculations where like at the bottom of the house, you got a concentrated load of like 20 or 30,000 pounds that you got to deal with. And you know, that's no good. So, well, it's not no good. It's just like, this is the way it is. So you got to be aware. Things that also make that happen are if the walls are super tall, then you actually have to deal with a buckling factor, which makes things kind of noodly, right? So if I have a little post that's this short and I put, 1,000 pounds on it, no one cares. But if I have a post that's the same dimension and it's this tall and I put 1,000 pounds on it, we all kind of understand that this thing might want to go like that. It's going to want to bow, and that's called buckling failure. And the height of this reduces the weight capacity that you can put on top of it. And so tall walls need more studs to make up for the buckling failure part. Okay. But these are 10 foot and 9 foot. These are relatively short. I'm talking 12 foot, 14 foot taller, 20 foot walls. Okay. So that takes care of that. Posts and walls. All right. One more thing. Obviously, inside the walls, you have headers. Like everywhere there's a window or a door. I'm not going to go like outline all of them, but like you get the idea. If you're doing a plan, you want to do a framing plan, you want to be like, I don't want to forget anything important. Go around and highlight all the windows and doors so that you'll be like, oh yeah, there's headers there. And I will show you something that is something to pay attention to, which is why we pay attention to the headers. Okay. There's something going on in this plan. That is one more thing we need to verify that works, and that's right here. Depending on where you put this beam, it might put the concentrated load on the header of the window right below it, which is a lot of weight to be putting right over a window. And so either you look at this and you're like, oh, I could just offset the beam over. I could just put the beam here so it lands in the wall and I don't even have to worry about it. But if I do put it here, I want to check with a calculation or just like put a fat header in here so I know that weight's distributed evenly. I don't have a problem over my window. Okay. So you got to watch out for something sitting on something else. That's the idea. Of course, if you guys have any questions, you are more than welcome to ask them and learn about what all these scribbles mean. I've got a school server where I can be accessible. If you want to join it, I think there should be a link in the description below. Come on, join the school server. It's totally free. And you can learn more about this stuff if you want to learn more about it. I also draw these plans. So if you want to check that out, that's where you can get a hold of me as well. Okay. Floor blocking, attic storage. Okay. We don't have any floor blocking. There's no floor systems in this house, this design. So we're not even going to worry about it. But what we will do is talk about one more thing, which is the attic access door over here in the hallway. This dude right here. We need to put a hole in the ceiling platform so that we can get through the ceiling with this attic access door. So I'm going to make a note here, just outline this thing with blue. All right. So I'll just pay special attention when I'm framing to not forget that hole that needs to go in the ceiling. And typically these attic access doors don't complicate the framing very much, but you do need to remember that they're there. Otherwise you can't get in your attic. That's pretty much it, folks. Oh, I didn't put any ceiling joists on the front porch. Let's give some ceiling joists there so they can have them. Oh, there goes a marker. Okay. So that's a framing layout as an engineer. Again, I don't know any numbers. I might move beams, I might move braces, but this is how I would approach the house design and be like, all right, I'm going to go put this all in CAD now. Oh, there goes my screen. Try again. I'm going to go put this all in CAD now, make this formal, put some stamp on it, put some calculations in there so that a framer can use this as a takeoff tool and know that if they follow the plan, that this has been maximally efficiently thought through with a big brain and not guessed at by someone who doesn't know what they're doing. So that's what we got going on. Quick little chat shout out. Thank you for Stevenson for showing up. Like that smash button. That's right, folks. Like the smash button. And we even got Charlotte Nightstar the Werewolf. Hello, Charlotte. How's it going? Been a minute since I've seen you, but I also have been taking a break from streaming for a little bit while I get the studio fixed. Good to have you. Good to have your support. Good to have your presence. This is great. I hope this has been educational for you guys. And again, I'm going to do this every Friday on a different house. Hopefully, I'm drawing houses faster than I'm doing this, and therefore I will not run out of things to show you. But this is it. We'll just do it again next time. Appreciate y'all for coming, and let's listen to one more beautiful thing from Mr. Hahn himself.
That's the code.
That's right, folks. That's the code. Let's take it out. Here we go. Thank you for coming on.